Alrighty, in this video we're going to actually talk about simplifying rational expressions, multiplying rational expressions, and dividing rational expressions. Okay, basically a rational expression is just an expression that is a fraction, and the numerator and or denominator contains variables. So if you look at this problem, 12x plus 20y over 3x plus 5y. One thing, please do not just start canceling like this. Do not ever do that because of this plus sign and because of that plus sign. You can only cancel like that if you have a product, not a sum like we do here. So, we need to see if we can factor this into a product and then see what happens. So, let's see, what can we take out of the numerator, 12x plus 20y. It looks like we could take out a 4, and 4 times 3x, okay, would be 12x, and then plus 5y over 3x plus 5y. Okay, now this 3x plus 5y, there's really a 1 out front. Now we can cancel out that. That 3x plus 5y as an expression becomes a common factor. Our numerator is 4 times the quantity 3x plus 5y. The denominator is 1 times the quantity 3x plus 5y. And this simplifies to 4 over 1, or just 4. Okay, so when you want to simplify rational expressions, first thing is factor the numerator and the denominator if possible, and then cancel out common factors. And your factors are going to be expressions now. Okay, let's look at this problem. Multiply 4a squared over 3b times 9b cubed over 2a. Now, just off to the side, if you've seen this, 2/5 times 10, we'll say 10/24, which normally it wouldn't be written that way, but that's fine. You've probably cross-canceled. 5 and 10 have a common factor of 5, so you would do that. And then 2 and 24 have a common factor. Then you would do that, 2 and 12. And now over here, this 2 and this 12, you would cancel to 1 and 6, and your final answer would be 1 over 6. You can do the exact same thing in these kinds of problems. So you look at the numerator, 4a squared, and then the other numerator, 9b cubed as well. And then you look at the denominator and see if there's common factors. Well, 4 and 2 have a common factor. Divide each one by 2. So 2 and 1. 3 and 9 have a common factor. 3. Divide each one by 3. Now over here, the a squared and the a, this is an a to the first, remember. They have a common factor of a. So we'll have a 1 here, and then an a here. The b cubed and the b have a common factor of b. So if you divide each one by b, you get b squared. B cubed divided by b is b squared. So now we multiply across. So we have 2 times a times 3 times b squared all over 1. So that's going to be 6ab squared over 1, or just 6ab squared. Okay, so that is the simplified version of that. And then lastly, a division problem. So again, we have to make sure everything's factored. In that last problem, everything was really factored for us. But in a division problem, you first have to do one step. So we write down x minus 2 over x minus 5. We need to change the division problem to a multiplication problem. And the process, when you're dividing by a fraction, the rule is to multiply by the reciprocal. So we're going to write the reciprocal of our second fraction. Okay, now we need to factor. So you can't factor the first rational expression, but the second one you can. So x squared minus 3x minus 10, we want to find two numbers that multiply to be negative 10 and add to be negative 3. That's negative 5 and positive 2. So we're going to get x minus 5 and x plus 2. Now, our denominator, x squared minus 4, is a difference of squares. So x plus 2 times x minus 2. And now since this is a multiplication problem, we can look across all the numerators and all the denominators and see if we can cancel out any common factors. Well, this x minus 2 cancels with this x minus 2, leaving us with just 1 over 1. This x minus 5 cancels with this x minus 5, leaving us with 1 over 1. And look at this. This x plus 2 cancels with this x plus 2. So we actually get 1 times 1 times 1 over 1 times 1 times 1. That's 1 over 1, which is just 1. So that fraction simplifies, that rational expression there, dividing the rational expressions, simplifies to 1. That's the final answer. Okay, usually you stop when you can't simplify anymore. Alright, and this, not every problem is going to simplify to 1 or something like that. There would be polynomial expressions left in some of your problems.